reasons to pay more money to a bigger fish than someone like GoDaddy or Namecheap for SSL certificates is that as part of this chain of trust, the various browser manufacturers, Microsoft, Google, Apple, and so forth, they ship their browsers, Safari, IE, and so forth, with certain certificate authorities' own certificates installed. So in other words, it's up to those big companies of browsers to decide which certificate authorities should you trust. And some of those vendors, Microsoft, they might have a list of certificate authorities you should trust this long. Google's might be this long. Really depends on the company. So if you go to some fly-by-night operation, or you yourself digitally sign your own certificate, which is mathematically possible, if you are not trusted, or that fly-by-night SSL company is not trusted by Microsoft or Google, you're going to get this kind of warning. So one of the things you're paying, and if you frankly are a Fortune 500 company and the difference between $300 or $1,000 isn't such a big deal, to make sure that more of your customers reach your website correctly, it might be worth spending more money. Because it could be that someone's got the latest version of Android and for whatever reason it didn't ship with the right certificates, or someone's using version 1.0 of Netscape or something like that, and so certificates aren't trusted inside of that. So again, you're paying to minimize the risk of users running into this kind of unrecognized message. But that's orthogonal to the expiration, which is just a matter of we let the bill lapse. Any questions? No? All right. So how do you actually configure this? Well, when you create your certificate running a command on a computer, you end up with two files. One is a key, and one is a certificate. The key rather, one is a private key, one is a public key. This line here, SSL certificate key file, this is literally where our private key can be found on the server. For security reasons, I have faked it as path to cs75.key, but it's somewhere on the hard drive. And I should make clear, it is not in the same location as your HTML files and GIFs, because that would be stupid if anyone could just download it. So it's somewhere else. The certificate key, SSL certificate file, this is what you're paying for. You upload your public key to GoDaddy or VeriSign. They then send you back via email or a download a digitally signed copy, which has your big number and essentially their big number. And then you install that here. And then lastly, this chain file just has to do with some SSL providers, whereby just in case one of the certificate authority certificates didn't ship with a browser, this chain certificate essentially says, we trust this person, so it's OK if your certificate's assigned by them. So I've glossed over some of the technical details, and it turns out, as maybe nice a theory as this is, SSL itself is still completely broken. Like, it can be circumvented. And I'll actually try to dig up an article, and I'll post it on the lectures page after tonight, if you're curious to see an interesting presentation on the various ways in which you can thwart SSL and trick users into thinking it's secure when it really isn't. So nice story, but the whole world is broken anyway. Any questions about SSL? There's one corner case that you need to be mindful of. When setting up your own website, running SSL on your website requires that you have a unique fill in the blank. Requires that your website have a unique IP. And this is one of the genuine gotchas with SSL. You have a sort of catch-22 with SSL. Because SSL is about encrypting information, what gets encrypted? Really everything in the request and the response. So everything inside of the virtual envelope is encrypted. What are some of the things inside the virtual envelope? Well, the get line, and also
the specific server you would be on a virtual.
Exactly. The host header, which tells the server which vhost this is for. But the problem is, as we're looking at the configuration here, every vhost can obviously have its own SSL certificate, because it might be foo.com, bar.com. These could be very unrelated entities if this is a snippet of a shared web host's web server configuration. So if you're getting encrypted requests, but the only way to figure out who the request is for is to decrypt the request. But to decrypt the request, you have to know who it is for, because the SSL certificate key, the private key you should use, is tied to that vhost. You again have this catch-22. You can only figure out who it's for by knowing who it's for. And so there's in theory workarounds. You could try all possible private keys you have on the system, decrypting it, but that's not necessarily deterministic, and it's also a little hackish, especially if you have hundreds of vhosts on a server. So the de facto result is that you just can't do it. But if you give every vhost a unique IP address and then associate effectively the certificate with that IP address, then you're safe. Because then you can just assume that if it comes in on IP address w.x.y.z, it must be using this SSL certificate. And there is one corner case. If you have a wildcard certificate, like we, the course, do, thankfully, with a wildcard, we don't need a unique IP address for all of our subdomains, FTP, mail, web, and so forth, because if they all come to the same server, you can use the same wildcard certificate to decrypt all of that traffic. So in short, when you sign up for a web host, if you want SSL, which frankly these days it's just a good thing to have, good practice to get into, it's probably worth paying a few dollars more to get a unique IP address, because otherwise your users will get that very scary red message. And Chrome makes it easy to click through. Firefox, you literally have to click like 5 buttons in order to get past the warnings. It's atrocious. No normal user will ever figure it out. So paying for an SSL certificate is sort of a necessary evil these days. The end result is great, cryptography, but a bunch of hoops you have to jump through. All right, so any questions? Yeah? By morning. I'll dig up the URL, and then I will post it on the lectures page of the website, so that if of interest, you can check that out. And let me just pull up our slides here. And go to, so what about this? This is among the more cryptic pieces of syntax that's useful to know, or at least get comfortable with, or get comfortable copying and pasting. Because with Apache, you can actually start to do fairly powerful things, and this is perhaps one of the most common. This is using a feature of Apache, and other web servers have very similar functionality, though they might call it something different, called URL rewriting. So mod rewrite just means module rewrite. This is an optional feature you can enable in the Apache web server that lets you rewrite URLs. Now, even if you've never seen this syntax before, what do you think these 3 lines of monospaced text are doing? Yeah?
Compensating for omissions and misspellings.
Compensating for omissions and misspellings? Sort of. That's actually a good thought. The only catch there is that if a user does mistype the address, it won't necessarily work unless DNS is configured to at least deliver the user to this endpoint. So in other words, if they accidentally type www.cs75.net, that will be a dead end unless we in DNS have allowed that to work with an A record, for instance, or a wildcard record, which is also possible. What else might this be doing, though? That's on the right track, though, and this is a very concrete case that we're solving.
Maybe it has something to do with checking if it's HTTPS.
OK, good. So is it checking whether it's HTTPS? So it's technically not, though it's very close to doing that. We could tweak it in a certain way. Yeah?
Is this kind of like a redirect type thing?
It is a redirect. And what's it redirecting from and to, do you think? From the top one to the bottom one, sort of. So that's actually pretty close. So let's start teasing this apart. So the very first line does what it says, turns the so-called rewrite engine on. If without that, also this is a common thing I often forget about, nothing's going to work unless you explicitly turn the engine on. So first line does that. Second line is a condition. So you can think of this as sort of a cryptic way of implementing an if-else type condition. So if the HTTP host variable. So what is this? Anything with a %, curly brace, and then a capital phrase like that. It's what's called an environment variable on the web server. There's a whole bunch of variables that are set just sort of automatically for you when a user visits. Among them is HTTP host, and that is a variable that specifies what is the IP address, or literally the word, the host name or domain name that the user visited. It's equivalent to the host line, if you will, from the HTTP request. So bang here is part now of a regular expression. So if unfamiliar, a regular expression is a pattern that you're trying to match. Bang is the opposite of true. So it means if the HTTP host is not going to match the following, don't proceed any further. So what are we trying to match? The caret symbol means what in a regex? Regex is a fancy way of saying regular expression. Not anything. That would be dot. Not any case. Caret symbol. Anyone else? Begins. Perfect. So caret symbol means the beginning of the variable's value must start with www. This is to avoid accidental substring matching, where you're matching part of the domain name, but not all of it. So this means you must start matching from www. In other words, the first letter in the host name must actually be www. It can't be xyz www. So www, I have a / dot. Based on what I just said about dot significance, what is / dot? It's an escape character, so it means literally a period. If you just say period, that means any character can be here. \dot is only a dot can be here. CS75.net \.net means it must match literally period NET. And then this, NC, is fairly arcane, just means no case. It's case insensitive. Doesn't matter if the user had the caps lock key on, this will still match if the word is correct. So if the HTTP host is not equal to literally www.cs75.net, proceed to do the following line. What does the following line say? This is a rewrite rule. So this is the, if you have an if-else, this is the if-then part of the expression. So if, then do this. So this thing here, let's come back to and focus on this. I am going to rewrite the user, rather redirect the user to https://www.cs75.net /$1. What does $1 maybe refer to for those familiar with regexes?
I think it's whatever the user typed in after .net.
Exactly.
So if you would have like a, yeah.
Exactly. So let's go back to this. What is this doing? Parentheses, in the context of regular expressions, generally mean capturing parentheses. So this cryptic sequence of symbols here means dot star. So dot is any character. Star means 0 or more of the preceding thing. So this means 0 or more characters, capture them. Where are you capturing them from? Exactly what you said. Anything after the slash that the user typed in is captured by these parentheses, and by convention is stored in a variable called $1. If I had a second pair of parentheses over here for whatever reason, then I would have access to $1 and $2 and 3 and 4. So it's a generic way of not knowing in advance how many parentheses you might have, but you can at least express yourself after the fact. So this just ensures that if the user visits something/ABC, I will not be redirecting the user to www.cs75.net. That's it. I will also have the courtesy of sending them to /ABC. And this is infuriating how few websites actually do this, especially in mobile phones. If you're in the habit of reading news or whatnot on your phone, this is a detail that drives me nuts. I'll go to like Google News, which has links to all sorts of websites. I'll click through, and for whatever stupid reason, the website will decide, oh, you came to us from Google News, but we want to show you the mobile version of our website, so let us send you to m.news.com. or whatever it is, completely forgetting what the URL was that you were at. So the end result is you can't view the article that you clicked on. Well, how do you fix this? Simple as something like this. Now, if they're not using Apache, it's going to be a little different, but the fix is fundamentally that simple, to remember what the user typed in. So again, in terms of user experience, in terms of running your own websites, super simple thing to do, and certainly to your user's advantage. Because if you're like me, you just leave that news site and never come back because it was annoying to visit in that case. All right, and how about a couple more technical details? R equals 301. Anyone want to guess what that's referring to?
Isn't that the redirect code?
Yeah, the redirect status code that we talked about on Monday. 301 means what specifically? Moved permanently. So this is in contrast with 302, which happens to be moved temporarily. Who cares? Like, why are there these two separate codes, do you think, whose functionality is essentially the same? Good. If it's a 301 and thus permanent, the browser, if it's smart, it will cache that response. And the next time you, the human, try to visit the same page, you're just going to be automatically redirected without wasting the server's time asking the same question. Whereas 302 means it's temporary. You probably should check back with me. So upside is you save a little time. The user gets a response a little bit faster. Downside, though, is what? What's the downside of 301, do you think? Again, start thinking about corner cases and problems you might be creating by trying to be helpful for the... What's that? In case it reverts back. Suppose that you just decide to reconfigure your server, or you change the name of it or whatever. You know, it's not something you do commonly, but the day you do it, are you going to be tricking your users into visiting a dead end? And so you have to be mindful, especially if you're the person doing the web server configuration, not the development of the website. You know, maybe we should make sure both of these continue working for some number of days or weeks so that anyone in the world who had cached this response finally reboots their computer or quits their browser. So these are the kinds of corner cases to be mindful of, especially when you care ever so much about uptime and making sure your users don't hit dead ends. L, probably wouldn't guess this. This means last. This just means if you have a whole bunch of these rewrite conditions and rules in the same file, This is just one of saying, that's it. Don't bother processing anything else in the file. We want this redirect to kick in first. So find fault with this. I'm kind of looking at my own line here, and there's technically a bug, even though it's not likely ever to be encountered. How could I have been a little more rigorous with defining this, do you think? And specifically, I'm thinking about my pattern matching. It's not quite as robust or correct as I think it probably should be, if you want to be really nitpicky. Yeah? Sure. Yeah. What's
I don't know if that would help, but you could add HTTP in front of www.
HTTP in front of www. Oh, good. So good thought. To put HTTP, it would actually break then, because HTTP host, the variable, is by definition, and you can only know this by reading the manual, does not contain the protocol. It only contains the host. How about if I point at the end here? What could I be doing better? Yeah. So good thought, too. Slash also, though, doesn't belong because it's part of the path, and the host is literally just the host. But it is something there. If you are familiar with regular expressions, it could be...
Something that corresponds to begins with the river.
Exactly. And for some crazy reason, you would like to think that, or it'd be a nice world if the caret symbol represented both the beginning and the end of a string, but the world chose $. So I should really put a $sign after the T here, because that would mean you have to literally match NET, and that's it. Now, why is that relevant? Well, it's probably not that relevant because I do not know of any top-level domains that exist today that are that start with NET and have more letters after them. But there is this tendency now where the world is creating much bigger names. And in fact, if you pay like $100,000, you can get .Google or .Apple. But someone could get .Network Solutions. And as soon as we do that, then again, the pattern match is not quite right. But again, it has no real material effect because if DNS weren't set up, the user would never reach me. But again, just a little thing to be mindful of, that it's not as precise as we could be. All right, so what is this? OK, that was really technical. Who cares? What is this really doing? Why would the user ever reach my website and not already be at www.cs75.net? What is the point of these 3 lines from a user's perspective, or really just big picture here? How else could you visit www.cs75.net, even today, with your laptops? Yeah. OK, FTP, but then this wouldn't even kick in because this is just web, just port 80, just HTTP. How else can you visit the course's homepage? Yeah.
There could be an error in one of the DNS servers that's sending someone to your IP address who doesn't intend to go to your actual site.
Oh, so that's good. So if there's a DNS error or there's just some maliciousness going on, you could be led to our website. And right, we did this Monday. What was the stupid little demo I did on the fly that made a certain news company look a little silly?
Change the name to CNN.
Yeah, right. I think I had davidnews.com all of a sudden, and we went there and we stayed there. And I mentioned at the time that CNN, if they just put like 2 lines of configuration in a file, they could fix this and immediately redirect the user to protect their branding so that it goes back to www.cnn.com. This is exactly the fix. Now, we're not doing it because we're worried people are going to come up with like fake cs75.com or stupid stuff like that, but just the simpler, what if they just visit http://cs75.net? Enter. We just decided as a course that, like most websites on the internet, we wanted to standardize, not on cs75.net, which we want to work, but we want to redirect the user so that they end up at www.cs75.net. Now, why? One of it's just, branding. If you want to, there's something to be said for just at least standardizing what your URLs look like, whether it has the www or not. But more than that, we mentioned briefly on Monday, and we'll revisit this in time, the cookie issue, whereby if you do have a subdomain, you can then isolate cookies to be part of the www subdomain, and they don't have to be global to your whole domain name, cs75.net. So in other words, all these lines are doing for us, and these are literally the lines we use on our own website. If I go to http://cs75.net, enter, where do I end up? Well, a couple places. One, I end up at www, just because. But I also end up at the SSL version, also just because. And then this is just because we're using MediaWiki, software that automatically makes the default page called main page for no good reason. So there's a few things going on there. So you can infer from this, though, how can you enforce use of SSL on your website? Suppose you're a bank. Suppose you're Gmail these days, and you want to force users to stay on HTTPS, even if they visit HTTP. How do you do it? Well, it's pretty much the same trick here. But rather than check the host name, which is not the problem now, you want to check SSL. So what you can really do in this case is instead a line like this. Rewrite cond HTTPS not equal on. So this is a slightly different syntax, but this is a different condition we could use that asks a different question. If the environment variable called HTTPS is not equal to on, what's the implication? It means it's off. And so what should you do? Well, if the next line is that same rewrite rule, you will redirect the user. So this is how you enforce SSL. This is one way you can enforce SSL on a website. Yeah?
And so this checks for every page. So say someone went to like wellsfargo.com/banking. That
Exactly.
would still work, and it would send them to the HTTPS.
Exactly. This will work for every page on the website because we had that additional use of the capturing parentheses to ensure that they don't just go back to the generic home page, which is just annoying, at least in my experience, but rather they go to / whatever they were at. And this gets installed, to be clear, either in that file called http.conf, but as you'll also see, there are per directory configuration files that Apache supports called .htaccess files, literally just a text file called .htaccess, and that syntax looks very similar to this, but you can't necessarily do everything in an htaccess file that you can in the main server configuration. It depends if people like us, the system administrators of a website, let you put certain commands in a directory. So you can use htaccess files to password protect directories, for instance, to change MIME type, so to speak, some fairly arcane details, but this is one of the most compelling. And there's actually another one. Facebook, if you're a user, many of the URLs end in what file extension, as we said on Monday? So .php, just because. Like, for historical reasons, they still use PHP for a lot of their front-end stuff, but there's no technical reason to expose what language you're using on your server. In fact, it feels like it's just a waste of 4 bytes, right? Why bother sending .php when it's strictly not necessary? And frankly, it's very Web 2.0 these days to have cleaner URLs, prettier URLs that just don't have cruft like file extensions. These http.conf and also htaccess files can also be used to let you avoid ever putting .php in your URLs. Your files on your hard drive can still be called hello.php, but the user could just visit /hello, and using mod rewrite, you can essentially tell the web server, if the file /hello does not exist, look for /hello.php, and if that exists, serve that up instead. Yeah?
No.
Okay. So a lot of power here. I will say, too, this is one of the things that frustrates some people, including myself, the most, because the slightest syntax error anywhere, if you get the permissions of the file wrong, your whole website can break. So it's a lot of power and a lot of trial and error and a lot of Googling sometimes to solve these problems. All right. Any questions? No? All right, so where can you use stuff like this? Well, next week when we start talking about the first project, we'll introduce this appliance, this virtual machine, in which you will have your own version of Apache running. But certainly after the course, or even during the course, if you want to experiment with other approaches, it's actually very easy to get LAMP onto your own computer. You don't need to pay for a web host. You don't need to set up a Linux computer. You can do it on your own Mac or PC. In fact, Mac OS these days comes with Apache, comes with PHP, comes with Python, comes with Perl. A lot of support for web programming related stuff built in, even though you sometimes have to run some commands to actually enable it. Your laptop is not a web server by default, even though Apache is in there if it's a Mac. Windows tends not to come with as much software along these lines, but either way, there's some packages, this is one of them, XAMPP, that makes it pretty easy to make a web environment on your own computer. Not necessarily for serving content to real users. We had that discussion on Monday that getting users from the outside world to your home with your cable modem and all that is non-trivial, and your ISP might not even let you or like it. But for development purposes, you don't need an actual web server per se. You don't need to pay anyone to start doing web development. You can do it on your own local hard drive, even if it's not static content, HTML files, but it's actually dynamic with something like PHP. So XAMPP is just the product name for free software that includes support for Linux, Mac OS, Solaris, and Windows. So it doesn't matter what OS you have. And it installs for you Apache, MySQL, PHP, and also even Perl, which is the other P in LAMP sometimes. Or actually, no, that's the P in XAMPP, not in LAMP. So what does this mean? It means you go to their website, which is, you can just Google XAMPP to pull up their page. You can install this software, and ideally, you then have some nice documentation locally, and your own database, your own web server, your own installation of PHP, so you can do all your development locally, which is nice because it's super fast, and it means you can work in a cafe or whatnot without even having internet access. There are some corner cases. XAMPP hasn't been the easiest historically to set up. Sometimes it doesn't quite work on everyone's computers, which is why we actually transitioned to the VM approach, where we can guarantee that everyone's environment is the same and works correctly. But certainly moving forward, when you no longer want to rely on course-provided software,